In linear algebra, most equations are looking for an answer. But homogeneous system is different. It is a system where every equation equals to 0. Hello everyone, my name is Syifa Nurul Fadilah, and in this video we're going to talk about homogeneous system of linear equations. But don't worry, I will also talk about determinants, elementary row operations, and in the end of the video you are going to understand about homogeneous system of linear equations. So let's get back to our discussion. Because it is balanced at 0, it is guaranteed to have at least one solution. We call this the trivial solutions. That means we only need to change the variable to 0. For example, if x plus y equals to 0. The easiest way to solve this equation is to change x equals to 0 and then y equals to 0. See, we have x as 0, y as 0, 0 plus 0 equals to 0. It is very easy, very simple. But in real-world problems, we often encounter problems that needs a non-zero solution, right? So how do we solve that? To solve that, we are looking for the non-trivial solution. This is the relationship where every variable balances each other out without being empty. So before we start calculating, we need to know if that non-trivial solution even exists. And this is when the determinant comes in. And for your information, determinant only works for square matrix. So for example, we have matrix A, B, C, D. So this is matrix A. If we calculate the determinant and then the result shows that determinant A is not equals to 0, this means the factors are independent. That means that they only met at one point. The solution is only x equals to 0. So if your determinant is not equals to 0, this means we don't have non-trivial solution. Sure. But if we have the determinant equals to 0, this is the jackpot. That means the matrix is singular and the equations are redundant. This also means that we have infinitely many solutions. So this is what brings us to non-trivial solution. But how do we calculate determinant? So we have an example of matrix A. The elements are 1, 2, 3, 4. And to calculate a 2 by 2 matrix, we need to stick to this formula, AB minus BC. So this is A, the 1 is A, B is 2, C is 3, and D is 4. Let's calculate this. 1 times 4 minus 2 times 3. 4 minus 6 equals to minus 2. And the determinant of A is minus 2, which is not equals to 0. But what about a 3 by 3 matrix? There's many ways to find the determinant, but in this video we are going to use elementary row operations. This is very practical, I'm telling you that. So when we are using elementary row operations, we have 3 tools. The first one is replacement. We can add multiple of one row to another row. And the second one is interchange. We can swap 2 rows to get our ones leading in place. And the last one is scaling. This means we can multiply one row with a non-zero constant. But when we use elementary row operations on determinant or to find determinant, we also have rules. So the first rule is when we are interchanging 2 rows or swapping 2 rows. We have to multiply our result later with negative. If you do interchanging or swapping rows once, you have the negative, and then if you do it twice, you have positive, and if you do it 3 times, you have negative again, and so on. So for example, you are interchanging 2 rows 1 times, and your result is 3. You have to multiply your result, which is 3, with negative. So your final result will be negative 3. So we have an example here. Matrix A, 2, 3, 4, 0, 1, 1, 1, 2, 1. So our goals is to make an upper triangular matrix using elementary row operations. Why upper triangular matrix? Because if we have a triangular matrix, no matter if it's lower or upper triangular, to find the determinant, we only need to multiply all the numbers in the main diagonal. First off, we need to find the pivot. What is pivot? Pivot is when we have 1 in our top corner. Let's take a look. We have 1 here. We have 1 at the row 3. We are going to swap these 2 rows. So we can have 1, 2, 1, 0, 1, 1, 2, 3, 4. Remember the rules. If we interchange or swapping 2 rows, we will add negative to our result. So we will multiply this later. So we are going to make an upper triangle, right? We need to make this 0. We already have 0 here, so we only need to think about this 2. How do we do that? We can use row 3 minus 2 times row 1. Let's do this. 2 minus 2 times 1. 2 minus 2 is 0. And then 3 minus 2 times 2 is 4. 3 minus 4, minus 1. 4 minus 2 times 1. 4 minus 2 is 2. We only need to change the third row. So we can write everything the same as before. The next step is we are going to make the negative 1 into 0. How do you do that? We can have row 3 plus row 2. So 0 plus 0, it will be 0. And minus 1 plus 1, it will also be 0. 2 plus 1 is 3. And we can write everything else like before. So this is our final matrix because it is already forming an upper triangular matrix. As you can see, we already have it upper triangular. So to calculate the determinant of an upper triangular matrix, we can multiply all the numbers inside the main diagonal. So 1 times 1 times 3 is equals to 3. But remember, we still have negative here from the swapping 2 rows earlier. So we can multiply our result, 3 multiplied by negative. It will be negative 3. So our determinant of matrix A equals to minus 3. Anyways, let's talk about the homogeneous system of linear equation again. So if we're done calculating the determinant and the determinant is equals to 0, we can move to the next phase, which is extraction. So in case you don't remember, we have 3 tools whenever we use elementary row operations. So we have an example here, and we are going to find the determinant first. Then we can find how to solve the homogeneous system. So we can first map it into a matrix first. So the first column will be x and the second column will be y. So the x are 1 and 3. Y is 2 and 6. For the complete form, we can add x and y equals to 0. Why do we map it like this? So if we perform a matrix multiplications, we will have 1 times x equals to x, 2 times y equals to 2y equals to 0. And we are going to calculate the determinant for, so if you remember, we can use a d minus dc, which is 1 times 6 minus 2 times 3 equals to 0. So our determinant is 0. This means our homogeneous system have infinitely many solutions, or we have the non-trivial solutions. So the next step is to make our matrix into a row echelon form. We're going to make this row 2, all 0. So 1, 2, 3, 6. Let's perform the elementary row operations. So to make the second row all zeros, we can have row 2 minus 3 times row 1. We can write the first row, and 3 minus 3 times 1 equals to 0. 6 minus 3 times 2 equals to 0. There we go. We have the echelon form. And for the easier one, we can make an augmented matrix like this. Just add a line. So we are going to identify the matrix first. So this is the pivot. The 1 is the pivot for the first row. For the second row, we don't have any pivot, right? So when we have a pivot, we call the variable as basic variable. In this case, our basic variable is x. And when we don't have any pivot on the variable, we call this free variable. And in this case, our free variable is y. So when we are solving a homogeneous system, we can set a parameter for the free variable. So let y equals to t. And after that, we are going to calculate it or substitute the t into our first equation. So our equation used to be like this, but we can have it like x plus 2t equals to 0. And we can perform things like this. X equals to minus 2t. So from what we have calculated before, we have x equals 2 minus 2t and y equals to t. Let's check. For example, the t equals to 2. So we have x as minus 2t. Minus 2 times 2 equals to minus 4. So x equals to minus 4 plus y equals to t. This is 2. So 2y. 2 times 2 equals to 4. So minus 4 plus 4 equals to 0. Let's take a look for the second equation. We have 3x plus 6y equals to 0. T is 2. So we are going to process this first. Minus 2 times 2 equals to minus 4. Minus 4 times 3, because our x is now minus 4. 3 times minus 4 is minus 12 plus 6 times y. Y equals to t, and t is 2. So 6 times 2 equals to 12. Minus 12 plus 12 equals to 0. So we have finally find the solution for our homogeneous system. The solution is x equals to minus 2t and y equals to t. So we have shown that if the determinant equals to 0, the system has a direction where every variable will balance each other out to 0. So whether you are solving a physics equations or calculating heat flow or game programming physics, understanding homogeneous system is the key to find stability in complexity. So I think this is the end of our video, and if you have any questions, feel free to write it down in the comment sections. And thank you guys for watching. I'll see you on the next video. Bye bye.